How are you guys today? So, what questions you guys have over L'Hopital's and stuff? We just work more examples. Okay. This is what I'm looking for. So let's do something like this. As x goes to infinity, this inside stuff, this goes to 1. This goes to infinity. So this is a form that looks like 1 to infinity, right? So this is another one where I've got an exponent. I want to get it down into something like 0 times infinity so that I can get it into 0 over 0 or infinity over infinity. So I need to use a logarithm here. So I'm going to set this whole thing equal to L. The limit is L. So we sort of assume the limit exists, and then we're going to take the natural log of L, because the natural log allows us to bring the exponent down. And so that's the limit of the natural log of 1 plus 3 over x to the x plus 1 is equal to limit of x plus 1, log of 1 plus 3 over x. And this goes to 0, and this goes to infinity. Okay? So now it looks like 0 times infinity. So we're going to make it look like 0 over 0, because I would like to keep the natural log on top rather than in the denominator of something. So we're going to rewrite this again. As the natural log of 1 plus 3 over x over 1 over x plus 1. So far, so good? Okay, now we get to differentiate both parts. By L'Hopital's rule. Hang on, let me just one over 3 plus x. No, let's leave it like that. We'll leave it as 1 over 3 plus x, because that chain rule is easy enough that way. Limit as x goes to infinity of 1 over this stuff. So, well, maybe I will keep that. One over the 1 plus 3 over x is equal to x over x plus 3. And then I have to multiply by the derivative of that, which is minus 3 over x squared. Good. And then L'Hopital's rule on the bottom, that's a minus 1 over x plus 1 squared. This x cancels with one of those. I end up with a quadratic in the denominator and a quadratic in the numerator. Just like simplify this algebraically. I have minus 3. Well, it's a plus because I got a plus here, or a minus down there. X plus 1 squared over x times x plus 3, right? And that my leading term is 3 on the top and my leading term is 1 on the bottom, so this goes to 3. And so natural log of the limit is 3, which implies L equals E cubed. Okay. Where do we have questions on that one? This technique, this is kind of nice to know because one of the common limit forms you might run across is one plus x over n to the n as n goes to infinity. That's what this is basically, n here and in there. It goes to e to the x. Okay. As long as this thing's like linear with a degree 1, we're going to go to e to the x, or with a monotonic, sorry, not linear, linear with slope 1. As long as that exponent's linear with slope 1, we go there. Otherwise, sometimes you might get like an extra factor down here of something, and so then it's not e to the x, it's e to the some fractional version of x. This is a common limit that shows up quite a bit. It shows up from compound interest. If any of you guys are business interested, this is a compound interest, continuously compounded interest. That's how you get that continuously compounded interest is p e to the rt instead of 1 plus r to the 1 plus r over n to the nt. Right. The limit as n goes to infinity. 1 plus r over n to the nt. If I put a t up there, I'd get like a t here. And so there's the limit of compounding at n times a year is the continuous thing. That's basically how that works. Okay. Other questions you guys have on L'Hopital's rule things? Yeah. Sorry. Oh, E. Yeah. So instead of taking the log, take E. Let's out. Maybe. I'm not really seeing anything in here that sticks out. First step multiplication. Let's see if I can come up with one that sort of works like that. So let's try limit x to 0. I don't know if this will work out or not, but this looks interesting to me. So let's try this one. So we're taking the natural log of the sine of x minus the natural log of 1 minus the cosine of x. I could do natural log stuff here. And so I think that's what I'm going to do is I'm going to do the algebra. So this is the limit x to 0 plus natural log of the sine of x over 1 minus the cosine. And I could have done the natural log first, or I could do e first. Either way, I'm going to end up with this is equal to L. E to the L is equal to the limit x goes to 0 plus sine of x over 1 minus cosine of x. Good with that? Okay, and then now I can take derivatives by L'Hopital's rule. This is the limit x goes to 0 plus of the sine of x goes to positive cosine of x. The cosine of x goes to the negative sine of x. But it's already got a negative on there, so it's going to be a positive sine of x, which is the limit of the cotangent of x as x goes to 0 from above, which is equal to infinity. So e to the L equals infinity implies L equals infinity. Does that kind of make sense? We could have got it to be finite if I would have done the other subtraction, right? If I take this minus this, what happens is it flips this fraction, right? Flips the fraction. And then if I flip that fraction, this becomes the tangent here. And the limit as the tangent goes to 0 is 0. So you get e to the L is 0, you get negative infinity, I guess, which would make sense because I just took the negative of what I took the limit of before. Okay. Other questions you guys want to talk about from the homework or other examples? Let's do another one. This one looks interesting. Go x minus the square root of x squared plus x. X goes to infinity. I got infinity minus infinity, but they're both growing around the same rate of speed, right? This is growing like x. This is also growing like x plus just a tiny little bit because that square root has an extra plus x in it. Okay, so how are we going to do this? Well, I need to use L'Hopital's rule somehow. So instead of doing the e to this stuff, which we could, but the better route is to rationalize this. So we'll do x plus x squared plus x over x plus square root of x squared plus x. and I get x squared minus x squared plus x over x plus square root x squared plus x. Limit x goes to infinity. And now I can take that cancels with that, and I get just a minus x on top. And on the bottom, I have x plus the square root of x squared plus x as x goes to infinity. And now I can do some arithmetic here. I don't have to, but I could use L'Hopital's rule, but I'm going to do some arithmetic first. So I get limit. Well, let's use L'Hopital's rule just because we're in the section where you're supposed to use L'Hopital's rule. I would probably just divide everything by x, and then this goes to 1, this goes to 1, this goes to 1, and this goes to 1 over x. And so it looks like it's going to be 1 over 2 with a minus sign on it. So this looks like minus 1/2 to me right now. But let's use L'Hopital's rule. So by L'Hopital's, this is the limit. X goes to infinity minus 1 over 1 plus, well, the derivative of that is 1 over the square root of x squared plus x times x with a 2 on it plus 1, because that's the derivative of the inside stuff. Okay. And then we can do some arithmetic. I guess basic algebra. So we'll end up with the square root of x squared plus x on top. We'll have a square root of x squared plus x and a 2x plus 1 there. That's got a minus sign on it. And now this is just getting messy. I don't know why it says to use L'Hopital's rule, because that just gets messy. But the book says use L'Hopital's rule. The only place I could think of to use L'Hopital's rule is like right here. Oh, never mind. No, that's a plus, isn't it? I'm missing that. That's a plus. That makes things slightly easier. Okay, let's use L'Hopital's rule again. Maybe. I've got 2x plus 1 on top over, I'm missing a 1/2 somewhere too, aren't I? There should be a 1/2 there. And that 1/2 goes there. And I should get a 1/2 here, square root x squared plus x. Still got a minus sign floating around there. Here, I've got a 1/2 2x plus 1 x squared plus 1. Sorry, square root x squared plus x. And then I've got a plus 1. And this is just going to keep giving me the exact same thing. So I don't know why it wants us to use L'Hopital's rule. Let's just do the algebra and ignore that the book says use L'Hopital's rule. Unless somebody sees how to use L'Hopital's rule, that is there some algebraic manipulation you can get that the derivative doesn't kind of get all screwy? Okay. So we're going to do algebra. I'm going to divide everything by x. So that becomes a -1, that becomes a +1, and this stuff becomes a 1 plus 1 over x. And now this is easy because this goes to 0. So you get -1/2. What do you guys think about limit x tangent 1 over x as x goes to infinity? What should we do? Yep. Right now this is infinity times 0. I want it to be like 0 over 0, so we're going to put tangent of 1 over x over 1 over x because that's the same thing. Multiplying by x is the same thing as dividing by 1 over x. Now I can use L'Hopital's rule. So derivative of the tangent is the secant squared. Multiplied by the derivative of the 1 over x bit, which is going to be minus 1 over x squared. And this is also going to be minus 1 over x squared. So those are going to cancel. And this is the limit of the secant squared of 1 over x. Since the secant's continuous, well, it's continuous at 0 at least. This is equal to 1 because the secant of 0 goes to 1. What do you guys think about this one? Sorry? It will sort of repeat until a point. So let's at least do this a couple times to get rid of the polynomial bits. So I'll get just 3 plus 2e to the 2x, and I'll have 2 plus 3e to the 3x. We'll do it one more time. I'll have 4e to the 2x over 9e to the 3x. And now that's going to be the limit of 4/9 of e to the minus x, which is equal to 0. Does that make sense? And you can kind of tell that right away because this denominator, it grows faster than the numerator, right? These are both exponentially growing. This is growing at a rate of e squared. This is growing at a rate of e cubed, right? So that one's going to go faster. Yeah. Sorry? 5? Okay, so 9x squared plus 8x over 4x cubed plus 8x plus 7. Okay. Right now, this looks like infinity over infinity, so L'Hopital's rule says we can take the derivatives. 18x plus 8 over 12x squared plus 8. We can do it again since it still looks like infinity over infinity still. And I get 18 over 24x. This no longer looks like infinity over infinity, so I can't do infinity over infinity anymore. But the numerator is fixed at 18, the denominator still goes to infinity, so a fixed number divided by infinity goes to 0. Yeah, and then you get 0 over, yeah. But technically you're not supposed to be using L'Hopital's rule unless it looks like infinity over infinity or 0 over 0. Yeah. So this is probably asking you for like 18 over 24x. Yeah. And then as you do it the other way where you divide everything by the biggest factor, the biggest thing here is an x cubed, right? So if I divide everything by x cubed, looks like I end up here. Nine x squared divided by x cubed is 9 over x. 8x divided by x cubed is 8 over x squared. 4x cubed over x cubed is just 4. 8 over x cubed is 8 over x squared. 7 over x cubed is 7 over x cubed. So that looks like what we do there. And then we say either way, this thing goes to infinity on the bottom, so that goes to 0. This thing, that goes to 0, that goes to 0, that goes to 0, that goes to 0, that goes to 4. So this looks like 0 over 4, so it goes to 0. Okay. Good. Questions on that one or other questions? Anybody online?
15?
Yep, sorry, which one?
15.
15? Okay. This is one where we get to use the e to the x thing again. So let's look at this. right now this looks like infinity minus infinity, right? Because it looks like 1 over 0 minus 1 over 0. So let's try to rewrite this as, yeah, I think this will work. Not, we'll have to try something else. We'll call this L. E to the L then is limit x to 9 plus e to the 1 over x minus 9 over x minus 8. Good with that? Let me do more steps. That's skipping a few things. And actually incorrect. So it's a good thing that I didn't write that down. Okay. So this is limit x to 9 plus. Here I've got e to the 1 over x minus 9 over e to the minus 1 over natural log of x minus 8. That's a plus now that it's in the denominator. This looks like e to the infinity. This looks like e to the infinity. So this is e to the infinity stuff. This looks like it's just going to get messy doing it this way. Let's try a different method. Because I don't want to take the derivative of that, because it's just going to give me e to that thing again times 1 over x minus 9 squared. And this thing is going to give me e to that thing again times 1 over x minus 8, which does get rid of the natural log, sort of, but let's do it a different way. Let's just look at that whole thing. And we'll find a common denominator. I'll take natural log of x minus 8 minus x minus 9 over x minus 9 natural log of x minus 8. And now I have 0 minus 0 over 0 times 0. So this still looks like 0 over 0. And we can use L'Hopital's rule on 0 over 0. This will turn into 1 over x minus 8 plus 1 over, nope, just plus 1, minus 1. Minus 1. And this will be x minus 9 times 1 over x minus 8 plus natural log of x minus 8. And so this looks like, what does this look like? That looks like a 0, that looks like a 0, so I still have 0 on the denominator. And in the numerator, what do I have? I have infinity minus 1. So this looks like infinity minus divided by 0, which is going to be just absolutely huge, right? It says type an integer. Is infinity an integer? Doesn't like that. What did I do wrong? Oh, that's an 8. That's what I did wrong. Now it's 0 over 0 again. Okay. Derivative of natural log of x minus 8 is 1 over x minus 8. And that gives me a 1 down there. So that's a 0 again. Okay. That's better to know. Okay, so I got 0 over 0 again. We get to take another derivative. So derivatives again. And now I'm just going to have a 1 up top, so I'm not going to have an indeterminate form anymore. So that's promising. On the bottom, that's going to be a x minus 8 under it with a plus sign. If you use the quotient rule here, low d high minus id low over square what's below. Let's simplify all that by multiplying everything by x minus 8 squared. So I'll have a minus 1 if I multiply the top by x minus 8 squared, and the bottom I will have an x minus 8 minus an x minus 9. And if I multiply this by x minus 8 squared, I get an x minus 8 up top. As we go to 9, this goes to 1. This goes to 0. This goes to 1. So this goes to 1 over 2, which is minus 1/2. There we go. Okay, questions on that one? Sydney, that good?
Yeah.
What other thoughts you guys have? Questions you want to see? What do you guys think about this one? What should we do with it? It's already in 0 over 0 form, so just L'Hopital's rule right away. So I get the cosine of x minus 1 over x squared with a 3 down there. Then what? Still looks like 0 over 0. So we get to use L'Hopital's rule again. Now I get a minus sign. That minus 1 goes back to 0. I get a 6x. And now we can do it again. Or we could recognize that we know what sine of x over x looks like. That goes to 1, right? But L'Hopital's rule works still. As x goes to 0, cosine goes to 1, so this is minus 1 over 6. About this? X goes to infinity there. And it's infinity over infinity, so we can use L'Hopital's rule right away. I'll have 1 over x times natural log of 2. And this would be 1 over x plus 3, ln of 3. Yeah. So the natural log of 3 over the natural log of 2, which is log 2 of 3.
Would you do it the same way if instead of in the numerator, instead of a log, it was the natural log?
Yeah, because then the natural log's base e. So you could if you had a natural log up here, that's the same thing as log base e of x. That didn't look. Log ex is the same as the natural log. So all that would change is that becomes an e, which is 1. So yeah.
Okay.
Any last thoughts? Yeah. Change the base formula. Log a of b is log c of b divided by log c of a. So in this case, here, c is e, which turns into here. This is a polynomial. This is my leading coefficient. That's my leading coefficient. Where'd the x go? So like if I had 2x plus 1 over x, right, then I have just 2 over You can use L'Hopital's rule again. Now these are just constants. That x times a number plus another number. That's just a linear. This is a line. This is also a line. So you got a line over a line. You just divide by the leading term. Okay, I will see you guys tomorrow. We'll go over 4.6. Some optimization stuff. That's fun.